Alright folks, how are you going? Well, today we're going to have a look at a particular model. Now, one of the things that we hear from flat earthers a lot is that the sun is something that's close, an object that's close. Some of them describe it as a hologram, others describe it as a projection. They'll come up with all sorts of weird and wonderful explanations for what the sun is. But mostly they say that the sun is close. So from a few thousand miles, if you like, down to a few hundred miles, and some even say less than that. So what they're saying is the sun is a very small object. Some of them won't even describe it as a sphere. So let's have a look at why this their model is impossible. Okay, all right. Now it seems silly that I would be even arguing this point, but I mean, there's enough of the flat earthers around who think the nonsense that I think it's worth probably just going through this, and maybe, you know, even if you're not a flat earther, you might learn something along the way. So let's start. First of all, I'm talking about a model. So I went in the last video, if you listen carefully, I described what science does in terms of models. Okay, so this is a model for the sun, which means that it's an idea. This is what the sun is, does, works like, and here is the evidence supporting that model. Okay, if and when something better comes along, that model might change, and very likely will change at the fringes, because right now there's a probe actually at the just about at the sun's corona, and taking some pictures and collecting data, and this is likely to result in different things being added to the model that we currently have, and perhaps even taking some things away. We'll see. Okay, so our sun is a G2V yellow dwarf. Okay, all right. So this is a designation for the hotness that the G is, the G2. So it's about the second hottest, and turns out to be V is designation for yellow dwarf. Comes out at 5.8 by 10 to the 3 Kelvin, so 5,800 Kelvin or thereabouts. Okay, and by the way, it's got a name. Okay, it's called Solus. Okay, so we call it the sun, but it actually has a name. It's called Solus in Latin. Okay, so what is it and what's it doing up there? Well, first of all, it's orbiting itself, so it's in orbit itself, and we are in turn orbiting it. So if you want a comparison with that, it's like the moon orbits us. Okay, and we orbit the sun. Well, the sun has its own orbit, and it has its various planets orbiting it. Okay, in our solar system. Okay, so what is it? It's a fusion reaction, fusion reactor. Okay, and let's see what happens during that. So two protons fuse. Okay. Two protons fuse, and sometimes one of them becomes a neutron. All right. Okay. So the neutron we get a positron and a neutrino. Okay. And after that, the next phase is the proton-neutron pair, creating deuterium. Okay, which is a form of hydrogen. And after that, additional proton collision with the deuterium creates helium-3. All right, and helium-3 plus helium-3, two of those colliding together, ends up creating the helium-4. Okay, creates the helium-4, and the helium-4, as a result of that, produces two neutrons, which in turn end up producing gamma ray photons. Now, these photons take hundreds of years, no, thousands of years, hundreds of thousands of years. Well, less than 200,000 years, more than 100,000 years, to get from where they reacted in the sun back out to the outside of the sun, and then along the way they change from gamma rays. This is high energy gamma rays, and become low energy or lower energy light and other photons like UV and X-ray. Okay, now only about 0.7% of all of the mass of the sun ever goes through this, so that ends up putting out this energy. Only 0.7% of the sun ends up putting out this energy, and this the T, what means the time, the number of times it takes to do it once. That happens 9.0 by 10 to the 37 times per second. Per second. Now, this is a very, very, very big number. This, okay. So I want you to think about that, about how big that number is. Okay. All right. Now, so as a result of this, we get helium-4, and helium-4. Well, most of us who done any basic chemistry will be familiar with helium-4. Helium-4 having 2 protons, 2 electrons in the S shell, and 2 neutrons. Okay. All right. How much energy do we get from the sun? Well, 3.8 by 10 to the 26 joules per second. Imagine that, eh? That is a lot of energy from the sun. So now, bearing in mind all of that, so the gamma rays, which are internal, and arguably some of them make it out. The X-rays, which are ionizing radiation for us. The heat, which is 5.8 by 10 to the 3 Kelvin. All of that in a small local sun. What protects us from this local sun? This is what I'd like to know from the flat earthers. Okay, folks, that was short and sweet. Well, I think that's probably what I'll do from now on. I'll just make much shorter videos that people watch right through. So the long videos tend not to be watched right through, which is a bit of a shame because people miss out on information. Okay, now what's going to happen next is I'll just follow this up with the stuff that you can see on the board over here. So we'll go through that with respect to the heliocentric model and also the flat earth model. Okay, alright, so let's end this video. Please press the subscribe button. At the moment the subscriber count's gone really well and approaching 1,000. It'd be nice if this video actually took it there. But anyway, if you do like the video, then please press the like button for sure. And if you didn't like the video, then of course, you know, by all means press the dislike button. But in any case, press the subscribe button and the bell, and then you know that when the next one's coming along, which will be very shortly, okay? Which is what's on the back, on the board over there. I'll see you next time.